This is the Water Quality Association podcast, promoting the betterment of water quality around the world. And hello, I'm your host, Wes Bleed.
We always like to say that, today's urine is tomorrow's coffee, so drink up.
That's Dr. Jill Williamson of NASA talking about water filtration on board the International Space Station. And welcome to the Water Quality Association podcast, the weekly podcast from WQA, the leading voice of the residential, commercial, and industrial water treatment community. Find us at WQA.org. If you're a first-time listener or viewer, welcome. We're glad you're here. If you've joined us before, welcome back. Be sure to subscribe to the podcast so you never miss a show. That's the magic of podcasting. And be sure to share the podcast with someone you know. Just forward a link. We also feature our podcasts on YouTube. Go to youtube.com/@WaterQualityAssociation videos. As we mark WQA's 50th anniversary, we're featuring some of our more memorable podcasts, and this one we go back to July of 2020 and our conversation with Dr. Jill Williamson. She's from NASA, and we had an interesting conversation about water filtration way up in outer space on board the International Space Station high above the Earth. Dr. Williamson explains how all of the water is captured and filtered and reused by the astronauts aboard the International Space Station. This was an audio-only podcast back then, so no video version is available. Later, we'll have our WQA tip. It's all coming up on the Water Quality Association podcast. Well, you may have thought that water filtration was such a complicated subject that it was almost like rocket science. Well, in some respects, it really is. In fact, our guest today knows all about it because she's from NASA. And we are welcoming to the program Dr. Jill Williamson. And she is, let me get the title right here, Jill. She's the ECLS UPA Subsystems Manager. And I'm going to have to ask you to explain what that is and tell us a little bit about what you do. So welcome to the program, Jill.
Well, thank you for having me. It's an honor to be able to tell our story about how we keep our astronauts happy and alive on the space station.
That's for sure. Yeah, great. And we're so excited about it these days with the new SpaceX program, and it was fun to watch the Dragon dock, obviously take off and dock, and soon they'll be coming back. So again, let's
right. So it's exciting times, particularly because it's been over 10 years or near that of being able to launch our own crew from our own ground. And so with the retirement of the shuttle, years back, we didn't have that resupply frequency. And so think of all the things to keep astronauts happy and alive, right? Food, water, science, we didn't have that resupply frequency. And so we had to look at the hardware for maintaining good air quality and water supply, oxygen, CO2 management, that we had to close the loop, essentially, right? We didn't have that resupply. And so where I come in, with the Environmental Control Life Support Systems, ECLS, that NASA loves our acronyms. So we keep throwing them at you as often as we can. But my part in that story of ECLS is within the water recovery system. And so part of closing the loop is reclaiming and recycling all sources of water. And you think of water in a closed environment. You've been in your car when it's raining, you get that kind of foggy consistency, the condensate on your windshield, right? The humidity is coming out of your breath, your perspiration. And so we have to manage the humidity. And so we have condensate, where we're basically using the think of your AC system at your house, you have a
Hmm.
heat exchanger, a hot side, cold side, and we'll condense the water and all the other condensables, and we'll push that through our water processor assembly. So humidity is one of our water sources, but of course the other major source is urine, and so that's my specialty. Fortunately, unfortunately, but it's a great subject to be in, where we're reclaiming as much water as we can from urine. And so we had to have a dedicated system to recover the water from urine. And so I get to play with pee every day is what I get to claim.
What an interesting subject. And again, this is all taking place on the International Space Station.
Correct. Yeah.
Okay.
So we've had our systems basically full force since 2008. And so we've had manned space station for many years. And in about 12 years of that, we've had the urine processor assembly along with the water processor assembly.
So, can you take us through the process
I
and
sure
just
can. Yes.
and let us know what goes on?
Right. So our, at least with respect to the water recovery from urine, that our system is a batch system. So it's basically urine's going to have to sit around for a little bit, and we stabilize the urine to keep things from growing. We'll have kind of that that urea in urine can break down into ammonia, right? That smelly, gassy stuff, right? We don't, we have to stabilize the urine. So we actually use chemical to stabilize it. So it's pretty corrosive. It's an inorganic acid and an oxidizing agent. So for all you chemists out there, pretty corrosive environment, but it's what stabilizes the urine. And so we push that matrix through our system, and basically we're boiling away the urine. So think of a fancy still, and we boil the water away and we'll condense it downstream. But we actually do it under a vacuum condition, so we don't have to heat it up as much. And so if you're under vacuum, you have to put just a little bit of heat, and we're basically boiling away the water, and we'll condense it, and we'll recover water. Currently on station, we are near 87% recovery of water out of the urine. So we generate a brine, and so that's really nasty, really gunky stuff, that we just at the moment will kind of throw overboard. So maybe that shooting star you made a wish on, was that a star? Or so we'll end up having to trash our brine essentially at the end of the day. But we're actually looking ahead, trying to improve to where we're near 100%. But really, so the urine, we're about 87% recovery, but we generate a distillate, and it's pretty clean at that point, but we're going to further polish it and really scrub it. And this is where the water processor assembly comes in. So our distillate will combine with that condensate, right, your humidity condensate, and we will process that through pretty typical technologies for water cleaning. We have multi-filtration beds, and so things of like a sorbent that love to absorb inorganics and non-volatile organics, and then anything left will go through a catalytic reactor, and we're basically oxidizing most everything else, microbes and any of those kind of smaller volatile organics will just basically get obliterated. And at the end of the day, we have super clean water. We'll final polish it. We'll add some iodine as our biocide. And so to keep things from growing after everything's all clean and scrubbed, got to keep it clean, keep things from growing. And we'll actually use iodine as our kind of biocide of choice. And then it gets delivered to a storage tank for use by the crew, either for drinking, food purposes, or for some payloads experiments.
What would you describe, Jill, as the state of that clean water ready for use? Is it like a distilled water? Do you put anything back in for flavoring? Any mineralization or anything like that?
Yeah, what comes out of our system is cleaner than what you drink here terrestrially. And so it is essentially distilled water. One of the reasons why we do that is, well, you are recycling your water over and over and over again. So you want to start off really clean. But really, it helps us to monitor our technology. Is something fatiguing, degrading? That if we have very low, we monitor for conductivity, so how much ions are in solution. And so if the conductivity starts increasing, we will see it easier when you have really, really clean water. So at point of use, it is really clean, very distilled, and so a crew is going to have to supplement their diet because of the distilled water.
Okay, yeah, interesting. We're talking with Dr. Jill Williamson from NASA, and this is really an interesting conversation about how you recycle and repurpose the water that's on board the International Space Station. So very interesting. Hey, is that the same process that's going to be used on the moon someday when we return?
So, what we have on space station, not just in the water world, the urine world, water world, but also the air world, and trace contaminant control, the technology on space station is the baseline for all of those future banned missions. We have so many years of experience and lessons learned that we can apply that knowledge for those manned missions. And so when we're looking to the moon and then forward still to Mars, that what you see on space station will be the baseline. Of course, there can be modifications to technology because once you get to partial gravity, any resemblance of gravity, sometimes that makes our jobs easier. We don't have to have all those little extra little widgets to make our technology work in microgravity. So, but we are looking to what we have on space station as kind of the baseline to get us to these other future manned missions.
Well, our members are obviously very concerned about water here on Earth, and we're always looking at ways to improve and, new technologies and so forth. What can our members learn from what you're doing in space?
Wow, that's always such a good question. That at least for us, we often will look to you guys out there that we will have our challenges, and when we get to a more sustained presence for these manned missions, we actually might actually look to you guys to help answer some of our problems, particularly with biofilm growth is also a pretty hot topic for us. So how do we mitigate or manage or prevent biofilm growth? That these are some of the kind of current challenges that we're actually going to be looking to industry, private sectors or wherever, to kind of help partner with us to solve some of these problems.
Well, that's certainly the way this is going now, with the SpaceX being this private-public partnership with NASA. So it's very exciting to know that it's it and optimistic as well.
Yeah, we look to as much partnerships as we can. We know we can't do it all on our own, and we oftentimes will have to rely on the outer world to help us get there. It's a partnership. The commercialization, the economy just really drives for this and yearns to get us there. So it's exciting times, and we always look forward to seeing what else the new state of the art will be, and it's exciting. Yeah.
Now, is there any talk or thought at all that you'll need to go up there someday to actually see how everything's working out and to see if everything you're thinking and doing here on Earth is actually working?
You're talking about me going to the
Yeah,
space station?
exactly.
So when I was a kid, I had thought, let's be an astronaut. That sounded so cool, right, as a kid. But then as I started getting older and starting to realize I get motion sickness pretty good, that I probably need to keep my feet on the ground. But how can I still be part of the NASA community, but
Right.
still be on the ground? So maybe not myself going up there, but this is where our future generations, these next generation scientists and engineers. These are the ones that are taking us to Mars. So we need to inspire them and keep them in this world.
Well, it is an inspiration, and a lot of our members, like me, grew up watching Jim Lovell and Neil Armstrong and all of the great astronaut heroes, and so it's exciting to know that this is still moving along, and that water is part of the story up there in space.
Right. Yeah. Water. We always like to say that, you know, today's urine is tomorrow's coffee, so drink up.
Hey, Jill, this was great. Thanks so much for doing this for us, and all the best to you and your staff and team there at NASA.
Absolutely. Thank you for your time.
Our WQA tip: you're invited to connect, inspire, and elevate at the 2024 Mid-Year Leadership Conference coming up September 17th through the 19th at a convenient Midwest location near Chicago's O'Hare Airport. Don't miss out on this collaborative, strategic conference for the water treatment industry. It won't be the same without you. Learn more and register at wqa.org/MYLC. Thanks for joining us for the Water Quality Association podcast, bringing you the latest news and insights from the association, our members, and outside experts to help you better serve your customers and grow your business. Learn more about water and water treatment at our consumer website, betterwatertoday.org, and learn more about professional certification, product certification, and how you can become a WQA member at WQA.org. Until next time, this is Wes Bleed. So long from the Water Quality Association.